Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at using trigonometry to find unknown angles. So in a previous video, we looked at using trigonometry to find unknown sides. So remember, we had to first decide which ratio to use, then we set up an equation, then we solve. So the process is very similar when we're finding angles. So let's look at this diagram here. So this time I want to find theta, which is an angle. I already know the lengths of the sides. So which ratio am I going to use? Well, I have opposite and hypotenuse. So remember, SOHCAHTOA means that I would use sine. Sine opposite hypotenuse. So I'm going to set up my equation just like I did when finding sides. So I have sine of angle equals opposite over hypotenuse. Of course, opposite goes on top of the fraction because it's listed first in SOHCAHTOA. So I want to solve this equation here. So this is where the difference starts. In the previous lesson, when we were finding sides, we either multiplied or divided here. We're going to do something different. I want to get theta by itself. So that means I sort of need to undo taking the sine of theta. How would I do that? Well, your calculator has a button that does that. It's called sine inverse. So to bring that up on your calculator, you have to press second or shift and then sine, and you should get this. So if I, for example, took the sine inverse of sine 30, I would get 30. The reason is sine inverse undoes sine. They cancel each other out in exactly the same way that multiplication and division cancel each other out, or addition and subtraction cancel each other out. So what I can do to solve this equation here is actually take the sine inverse of both sides. So I'm going to take the sine inverse of the left-hand side and the sine inverse of the right-hand side. So I can't put the left-hand side, I can't put this on my calculator. But because sine inverse and sine undo each other, this will just leave me with theta. That's what I wanted. I got theta by itself. And on the right-hand side, I have sine inverse of 9 over 14. Now, you can put that on your calculator. So if you put this on your calculator, making sure it's in degrees mode, the answer is almost exactly 40 degrees. So this angle here would be 40 degrees. And we're done. So you don't need to go through these lines of working out all the time. You can just go straight to here and write your answer. The first two not needed. So let's look at another couple of examples. So let's have a go at the two triangles down here. So we'll start with the one in green. So first we have to decide which ratio we're going to use. Well, we have the adjacent side here and the hypotenuse. Adjacent hypotenuse is cos. So we can skip straight to this step. So theta will be cos. Now, because we're finding an angle, we use cos inverse of adjacent over hypotenuse. So if we put that on our calculator, we get about 57.76. So that is to the nearest degree, 58 degrees. So let's look at this triangle here. So we have our angle that we're trying to find. We have the opposite and adjacent. Opposite and adjacent means I use tan. So theta will be tan. Now, because we're finding an angle, we use tan inverse. So opposite over adjacent. So because opposite is listed first here, it goes on top. And so putting that on our calculator, we get about 54.46 degrees. So to the nearest degree, that's 54 degrees. So make sure you remember this. We use sine, cos, and tan like we did last lesson to find sides. But whenever you're finding an angle, you need to use sine inverse, cos inverse, or tan inverse. Again, you get that on your calculator by pressing shift or second, and then sine, cos, or tan. So let's look at a couple of harder examples. So let's have a go at these questions here. So what's the smallest angle in a triangle with side lengths 5 centimeters, 12 centimeters, and 13 centimeters? Well, first note, 5 squared plus 12 squared does equal 13 squared. Pythagoras' theorem holds. So this triangle is right-angled. So let's draw a picture of a right-angled triangle. and we'll label the sides 5, 12, and 13. Doesn't matter if it's not to scale. So 5, 12, 13. Okay, now we know from previous lesson, the smallest angle is always opposite the shortest side. So the shortest side is 5, the smallest angle will be this one here that's opposite it, theta. So to find theta is really simple. Because we know all three sides, we could actually use any of the ratios. I'm just going to use sine here because I know it's opposite the side that's 5 centimeters. So because I'm finding an angle, I use sine inverse. So opposite is 5, hypotenuse is 13. The smallest angle always opposite the shortest side. So putting that on my calculator, I get about 22.6 degrees to the nearest degree. That's, of course, 23 degrees. All right, let's look at this next question. Now we're going to find the largest angle in a triangle with side lengths 10, 8, and 8. So this one is not right-angled because 8 squared plus 8 squared does not equal 10 squared. It's not right-angled, but it is isosceles because it has two sides of equal length. So the triangle is going to look like this. So it's an isosceles triangle. Now, we only know how to use trigonometry to find unknown angles when the triangles are right-angled. This isn't a right-angled triangle. But if you have an equilateral or an isosceles triangle, you can divide it into two congruent right-angled triangles. So this will be like one of the smaller right-angled triangles, and this side here will be half of 10, which is 5 centimeters. You can only do that if the triangle is isosceles or equilateral. That's the only time you can divide it into two congruent right-angled triangles. So here, I wanted to find the largest angle. So just as the shortest side is opposite the smallest angle, the largest side is opposite the largest angle. So the largest angle will be this one here. So what I can do, though, is I can find just this angle here, which I call alpha, and double it. These two angles will be the same. So to find alpha is actually pretty simple. I have a right-angled triangle. I have the opposite side and the hypotenuse. So it will just be sine, because it's opposite and hypotenuse, sine inverse, because I'm finding an angle of opposite over hypotenuse. So alpha is about 38.68 degrees. So that's half the angle. So the full angle there will just be double it. So it'll be about 77.36 to the nearest angle. It will be about 77 degrees. That's the largest angle of this triangle. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.